Let's talk chemistry. We're looking at one of the most important concepts in chemistry. Not that they're all important, but the mole is something we're going to use very, very strongly the rest of the year. So, therefore, we got to make sure we understand what we're talking about. If we have a balanced equation here and we balance through it, we see that 2 moles of SO plus 4 moles of chlorine is going to generate 2 moles of SF4 plus a mole of oxygen. Now, when you look at that, we try to figure out what units will we use to measure that inside there. And we tried grams. Grams didn't work because if I took 2 grams and 4 grams, I didn't get 2 grams. All right, how about volume? If I took 2 liters and 4 liters, would I get 2 liters and 1 liter? No, liters and 1 liter. So what did we come up with? It had a value called the mole. Mole is a unit of chemical equivalence in a chemical reaction. And it was first discovered by a scientist named Avogadro. He was a good Italiano. Yes, the wise, intelligent, the ever so handsome Italians came up with a concept of a mole. Now, what exactly is a mole? A mole is equal to 6.02 times 10 to the 23rd atoms or molecules. So it's a very, very large number. That's why I have to use scientific notation. All right, here's looking at a problem. How many moles are in 5.07 times 10 to the 24th molecules of SO? So we take our given and put it over 1. Now, our equality again is 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules. This is molecules. Now, remember when we do unit conversions, what we look at goes on the bottom. What we want are on top. That way, that's still 1. We're going to cross things out. So, therefore, the molecules cross out. Multiply through sig figs. We're going to use 5.07. Answer is 8.41 moles. All right. There's another one to do. And I'll just let you go from there. Try that one at home and we'll do it afterwards. Okay, we'll discuss if we have any problems with that one. Pretty straightforward. All right, now that's what we call molar mass. What is molar mass? Because of the fact that we can't do molecules. Molecules are way too small. Instead, we're going to use atomic mass, AM, if it's an element, or FM, formula mass, if it is a compound, in grams. That is also equal to a mole. They found out that if you convert the atomic mass, the formula mass into grams, that equals out to 1 mole. We also have what's called molar volume. Molar volume is for a gas. Now that's only a gas and only at STP equal to 1 mole. It's 22.4 liters every time, all the time, 3 times on Sunday. Why does it work out this way? It's just the equality that works out for volume of gases. The gases it has to be gas, can't be a liquid, can't be a solid, can't be a solution, has to be a gas, has to be something called STP. What is STP? Well, STP stands for standard temperature and pressure. All right, so let's take a look at one of these. Calculate the mass of 55.88 moles of silver iodide. All right, so take our given over 1. Again, set it up. Now, I need to find, this is a compound, so I'll need to find the formula mass. Formula mass, silver and iodine. There's 108 grams of silver, 127 grams of iodine. Together, we get 235 grams of AgI as 1 mole. We want to get rid of moles and into grams. So we set up 235 grams over 1 mole. We multiply through. My moles cross out. I'm in grams. I only had 3 sig figs. You multiply through, you get 1,380. Now, why do we cut it off there? Remember, there's only 3 sig figs. We want to conserve the 3 values. So even though the value is a lot different, it's only 1,380 is a comp we can do. Another one I'm going to give you. Try this one. It's straightforward with volume. That's going to be the 22.4. All right, let's do one last one. Now, we can do a multi-step equation here. This time I want to know what 38.22 liters of nitrogen monoxide gas is, and I want to know the mass. Now that's a volume. Remember we talked about volume? 1 mole is 22.4 liters. So liters are going to cross out. Liters are going to bottom, moles on top. So my liters cross out, I'm in moles. Now I want mass. Mass is going to be AM or FM. NO is a compound, so therefore it's a formula mass. The way that I always keep those straight in my mind, Atomic mass, element, both have vowels. Compound, formula mass, both are consonants, letters. That might help. So let's do the formula mass: nitrogen monoxide, nitrogen and oxygen, 1 in 16. So 30 grams is 1 mole, and we're in moles, so moles are going to go on the bottom, grams are going to go on top, so my moles cross out. We multiply through, take 38.22 times 30, hit equal, divide by 22.4, hit equal. How many sig figs? Always go back to here, because remember, both of these are inequalities. Inequalities are infinitely significant. All right, multiply through them, we get 51.19 grams. And again, one more I'm going to have you do. Try this one. And any questions, you can always email me. All right, lastly then, let's try 2 of these. How many molecules are in 13.35 liters of nitrogen? And how many liters are in 31.22 grams of oxygen? Now, I didn't specify that, but because I'm giving you volumes, or asking for volumes, you have to assume that both of these are gases. Nitrogen is a gas, oxygen is a gas, and you have to assume they're at STP. All right, pause the video, try it. Okay, let's take a look. Answer the first one, 3.588 times 10 to the 23rd molecules of N2. So we're going to cross out the liters, getting the moles, cross out the moles, getting the molecules. Okay, for the second one, answer is 21.85 liters of oxygen. Going to go from grams to moles, moles to liters. My grams cross out, my moles cross out, my liters, 21.8 because I have 4 sig figs. That's my answer. All right, hopefully that's not too bad. We will practice these tomorrow and go through the value there. Take care. God bless.